Hi, my name's David Langton, Product Director at Matillion. CDC, or Change Data Capture, is a technology for efficiently reading the changes made to a source database and applying those to a target database. Today I'm going to show you setting up CDC using Matillion ETL for Redshift, but the procedure for setting up CDC with Matillion ETL for Snowflake on AWS is almost identical. So let's get started. Before getting into the details of Change Data Capture, it's worth considering whether it fits your use case. Matillion offers the database query component, which is simple to set up, uses S3 to do an efficient bulk copy of the data. It can copy a query result rather than just a table. It runs on demand, and it can, with a little bit more effort, be set up to query only the changes, although that does require the source database to have the necessary fields so that you can tell what's changed. CDC is slightly more complex to set up, although Matillion will do much of that setup for you. It uses Amazon DMS, Lambda, SQS and S3 behind the scenes to orchestrate everything, and it's going to copy a selection of tables in their entirety from a source database. Bear in mind there'll be an incremental cost to AWS for using these services. CDC runs constantly, keeping tables more or less up to date, certainly to within a few minutes of the last change made to the source database, and this requires no additional scheduling. The big differentiator for CDC is that only changed data is processed without any special effort, so it scales to huge input databases where we're only concerned with the volume of changes being applied, not the overall size. So let's take a look at the architecture. There are some slight differences to this diagram during the initial load, but once you get into the ongoing change management, the source database is monitored by DMS. The DMS writes CDC change files into an input S3 bucket. That triggers a Lambda function which does two things. It writes the data out to an output bucket with line numbers added. That's required so that if multiple updates to the same entity exist in the same file, we ensure that the order is correct. It also writes a Lambda function to Matillion which triggers the job to process those changes. Let's see how we'd get all that set up. In order to get Change Data Capture working, we're going to need to create a few resources in our Amazon account before we get started. So if you head on over to the S3 area of the console and create a bucket for the purpose of CDC, if you don't already have one that you can use. The next place in the console you're going to want to go to is the SQS section. We use SQS as notifications in order to get Matillion to load the change files as they happen. So you can just hit New Queue. It will need to be a FIFO queue because you want to make sure the changes are processed strictly in order, and then just give it a name. It must end .FIFO, but all the defaults are fine, so you can just hit Quick Create Queue. So with our S3 bucket and SQS queues created, the next thing is to head on over to the DMS part of the console. Within the DMS console, you'll find replication instances. We're going to need to use a replication instance to listen for the changes on our source database and put them into S3. If you hit Create Replication Instance, in most cases the defaults are just fine. The last resources we need to create are some roles. If you head over to the IAM section of the console and created 2 more roles, Matillion is going to create a lot of resources in your Amazon account to power Change Data Capture. One of these is a Lambda function, which will require access to the S3 bucket and the SQS queues that we just created. And the other role is to delegate to DMS so that it can also use the same S3 bucket. You'll see here that I have my replication Lambda role. That both has the S3 and SQS permissions, which can be as fine-grained as you need. They only need to access the area of S3 that you require. The important thing is that there is a trust relationship to the Lambda service with that role. Similarly, for the replication instance role, we have the same policy that we need to access the resources, and the trust relationship here is DMS, so that the Amazon DMS service can use this role. There is a third role, which is the role attached to the Matillion instance. I'll cover that when we get to that point. With all of those prerequisites set up in the Amazon account, we can now head over to Matillion. We can enter a project that we'd like to use for CDC and then go into the Change Data Capture Management screen. For each project, there's some one-time setup that you can access by hitting the Manage button. When we were setting up the Amazon account ready for this, we created a couple of roles that were going to be used by the various services in AWS to make the DMS work. There's also a third role. That's the role we're going to use now in order for Matillion to create all of those resources. For a full list of the permissions needed, go over to our support site. In this case, I've ensured that the instance credentials attached to this machine can do all the necessary API calls. And that means I can now set the region, the queue, and the role on that we set up earlier. With all of that configured, we can now add as many CDC tasks as we want to this project. So let's add our first. For this example, I've got a MySQL database with the TPC benchmark data already loaded into it. That database is set up for binary logging, which means that it's suitable for change data capture also. So let's set this task up. We'll use the replication instance that we set up earlier. It is MySQL. You'll notice that because it's MySQL, a DMS connection attribute has automatically been set, but you're free to add and change any of the settings based on the database type, and it's all fully documented on the AWS DMS documentation. Once I think I've filled all that in, I can hit test and it'll just check some basic things, such as the binary login and the connectivity. Since that looks great, we'll move on to the next step. Now the source has been set up, we now move on to the target. With a batch interval of 300 seconds, we'll never be too far behind the source database. It's important in the table selection that we only include tables with a primary key, and for performance reasons, we probably only want to include tables that we're going to then use on the Redshift side. I'm going to include a default rule to include all the TPC tables, and then add a second rule to exclude one of them which I know doesn't have a primary key. I've got a couple of different schemas set up in my Redshift cluster so that I can separate the tables that are used during the copying of the changes to the target tables which have the full copy. The target table prefix in this case could be blank if I really wanted to copy the table names as is, but I'll prefix them all with target. And finally, this is going to generate a job in the project, and I need somewhere to put that. Now that's all successfully completed, we can complete this dialog for our first CDC task. I can choose to immediately run the task or defer that until later. Right now I'm going to say no. You'll see the monitoring is now creating all of the resources required for this, and when that's ready, I can begin the CDC process. And now we're really ready to get started. There are no target tables created at this point, but as soon as I begin this task, then the initial load will begin. What's going to happen now is DMS will query the source database for an initial load of all of the tables, but it will also record the time that starts. Once the table's been loaded, it will then apply any changes that have happened during that time window, and then it will go into a maintenance mode where all changes that occur in the future will be batched up, sent over to S3, and then processed by Matillion, and that'll all happen automatically. You can already see the initial loads have already queued up their loads, and that will just continue. Anytime you can hit refresh to see how far the initial load progress has got. If we take a look in the Amazon account now, you'll see that the bucket we created earlier is starting to get things added to it. The task was called demo, and there is an incoming folder and an outgoing. Outgoing is where we will clear up the resources as we go along, but incoming with all the changes are there until you decide to remove them from your Amazon account, which is easy to do, and you can create a policy to clean up these files on a time basis. There you'll see that we've got an initial load and a set of changes produced for the same table there. If we go over to the Lambda console, you'll see the function that was created and the fact that it interacts with S3 and SQS. If we look at the monitoring, we should see some recent activity. So back over in Matillion, all of our initial loads are complete, and now any changes made to that source database should propagate through within a few minutes. A little job will run and automatically update the table. It's worth mentioning at this point that this is all being powered by running this job and passing a bunch of variables into it. That means you can change or extend this job so that any time a file's processed, you can have your own custom logic inserted. Maybe you don't want to just keep a target table in sync. Maybe there's some more exciting things you can do with those changes, and this will be called to process each batch of changes on a per table basis. And just to make absolutely sure that this is all happening, if I go to the environments, I created a target underscore prefix for all the tables, and they are the tables that I expected to be synchronized. Great, I hope you found that useful. For more information, head to matillion.com or start a free trial of Matillion ETL on the AWS Marketplace. Thank you.